Hi, thank you very much for being at this first day of Websummit. I'm very glad to have this chat with you, Val Cook. Unfortunately, we were supposed to be three today with Walter Goodwin from Fractile, but he had to cancel yesterday. He's very, very sorry about it. So it's just going to be you and me. So that's your moment, Val. So I'm very glad we're going to talk about the next era of silicon today. And so I'm going to introduce you a little bit. So you are Val Cook, the co-founder of Blaize, which is a public AI computing company that created a new compute solution that unites silicon and software to optimize AI from the edge to the core. So my first question is very simple, and maybe for the ordinary people in the room that do not speak the geek language. But
there we go.
We live in the Nvidia world today. So can you tell us where you are based exactly?
So we're international. We're headquartered in the Bay Area. We have a presence in the Sacramento area, as well as the Research Triangle in North Carolina, India, and the UK. So various operations in different locations.
And can you tell us exactly what you do compared to, of course, I have to mention it again, Nvidia and all the the big ones in the area?
Yeah. So one of the key, I guess, differentiating pieces of Blaize's contribution is we genuinely believe in this idea of practical AI, where the concept is that there's a right solution for the right place and the right problem. And solving that whole problem is going to involve really bringing the right kind of hardware with the right kind of software to bear on each piece of that aggregated problem. And we're excited about that. We think that that's a key piece.
So what are today the main use cases that you focus on?
So many of our use cases are interesting in the sense that we like to talk about really smart urban infrastructure. And that urban infrastructure, we sometimes kind of revert to this idea of a smart city or something, but we're finding that it's a much larger story than that. As we talk with small local municipalities to countries, there's really a genuine desire to have a much richer, sovereign infrastructure, where the challenges that they have specifically are met and more importantly owned by them. And that involves a challenging framework to pull all of that together.
Mm-hmm. And how can those new architectures like yours, like Fractile, who couldn't make it, benefit the whole AI industry today?
Yeah,
exactly.
Great question. So I think one of the key pieces here is, if we look at this idea of physical AI, we often think of robots, right? And that's kind of the coined term right now. In reality, if we're willing to define that in a much larger scope, where we have physical operational observability, and that applies across a huge spectrum. If you can imagine grandma in her granny flat, she wants her independence, she wants to be alone, but you want to know if she left the burner on the stove, right? And you want to potentially even take action on that. All the way to the foreman at the construction site, who has just a tremendous need to know where the teams are and when the pumper truck's coming and where the forms are, and just this huge observability problem that's very different from sort of the security and surveillance mantra that sometimes we see. And so one of the key benefits that Blaize brings to that picture is this idea of practical AI. We can deploy AI close to the sensors. We can deploy AI next to the operations that we want to observe. And they can be a large variety. And then we can pull all that back into the cloud, where we need centrally controlled and shared resources. And building that sort of hybrid or heterogeneous architecture as a platform really is the benefit that we see, is changing changing the way we interact and rapidly with our machines.
Yeah, when we prepared this session a few weeks ago, you told me, oh, we have to talk about programmability. so can you tell us why it's important today?
So let me first maybe define programmability from this point of view. There is the idea that I can take my Lego blocks and I can have a block for this operation and that operation, and if I get enough of those blocks together, that I can assemble a model that I've got a programmable model. I can snap them together, and that's certainly a true definition for programmability, and the most common one today. Then there's the idea that, well, my chip is programmable by me, right? Internal engineers can program the device. And then there's kind of the traditional definition of programmability, where you expose to your users of your device the programmability tools, you build the compilers, you invest in the infrastructure to really make the device usable by programmers. And the traditional story behind programmability is future-proofing, right? That's kind of that, well, we can handle the inflection points or whatever, but a quick story. so it's the turn of the century, we're building GPUs, we're excited about it, and graphics has been programming a fixed lighting equation for a decade, right? And there were 41 companies, if my recollection was right, that were playing in the chip industry. And those 41 companies saw largely the game developers crying for more, right? They wanted to have a more flexible platform than this fixed lighting equation, and they were misusing the texture samplers and all kinds of things to do 4-dimensional table lookups and all kinds of goofy things. But the short end of the story is that 3 companies chose to go programmable, while the rest of those 41 companies had built the fixed function pipelines. And you can imagine who those companies might be today. ATI acquired by AMD, Intel, and Nvidia, right? And those 3 companies really survived. So there's this future-proofing survival story that's critical to going through that programmability effort.
And how are you going to survive? Because everything is going very fast in this industry. Every week there's like a new technology. Now we are talking about agent, coding agent. It was not the case 2 years ago. So how do you keep up as a small company, let's say?
So I can't claim that we foresaw this. We had these GPU experiences. We saw the advantages of a different architecture, but we knew we wanted programmability, and we knew we wanted to expose it as a direct feature to the customers. So that's benefited us in tremendous ways. If you can imagine, most of the vision-based applications in the physical world today are using declarative techniques. You sort of describe what you want, and you don't really write a program. We chose an imperative style to interface with the device. That imperative style has a programming language behind it that can do much more than host a model, right? And as we expose that in ways that are compelling and easier to use for our customers, well, the end of the story looks like this. You can prompt our hardware in the whole visual space and generate an imperative program that runs on our programmable device for your needs, right? You can say, tell me when Granny forgot to turn the burner off, right? And that kind of real benefit comes with programmability.
And we see a lot of new companies trying to go up against Nvidia. Sometimes they are very specialized, sometimes they're not. So they all have their specificities. So is it good? Is it bad? What do you think about that?
So that's a two-edged sword kind of question.
Yeah.
So I can almost remember the day. I certainly remember where I was standing. I was part of the industry standards bodies at the time, trying to define the programmable languages that would be used for GPUs. And Nvidia announced that they were going to build CUDA, right? And people were shocked, right? They said, how can they do that without the industry support? And many of us looked down their noses at them in a sense, right? But we look back now and we go, boy, what a strategically well-positioned choice they made, right? And they've built, in a very real sense, a moat around their hardware architectures with this wonderful software infrastructure, right? That companies like Blaize and others can't get across, right? It's simply too well established and too large. So competing with them directly is a challenge for sure. And from the software point of view, there are some advantages to not being in a moat. You know, moats keep you in as well as keep others out. And the concept in a nutshell is that if you have a software infrastructure that works cooperatively with this infrastructure, the way that we think of practical AI working at Blaize is we do the important parts, Nvidia does the important parts, and we don't have to go head to head with them, even at the architecture level. Right? There's a lot of excitement around in-memory architectures. Blaize is more of a data flow architecture, where you keep much of the data on chip. We're both interested in solving the same problem, data movement, right? We took different approaches to solve that, but the right answer, Blaize believes, is to do that in a practical way, in a heterogeneous architecture type platform.
And how do you see the industry, the landscape evolve in the, I would say, I wanted to say in the coming years, but in your case, more in the coming months, maybe a year or two?
Yeah. So the physical AI thing, I think, is the big thing. And we've talked a little bit about it, but I really genuinely believe that those of us that may have a security camera at home checking to see if a parcel was removed from our front porch, that's sort of a simple use case for where we're going. And I genuinely believe that will take an efficient solution, right? It will need to be cost effective. You just can't afford to send your porch camera to a hyperscaler data center to watch every frame of that video stream, right? And so solving those problems together will be key.
And what's today one of the biggest challenge you face, you, Blaize?
So I would say the biggest one is frankly efficiency, right? Is being able to solve the whole problem. When you define the physical world as broadly as Blaize does, you may need to do a color space conversion on an input image. Well, you can do that on the host CPU, but you can do it in a microsecond on your hardware if it's programmable. And you can do it efficiently, right? If you need to, essentially the entire infrastructure needs to be acceleratable in a heterogeneous platform, and doing that with efficiency is the real challenge.
Okay, so I wanted to talk a little bit about Nvidia, of course, because now it's like the market cap is like crazy, 5 trillion. So what do you think about that? You know,
you're going to have to ask that again. I missed the key part of that.
I think Nvidia now has a market cap of $5 trillion. So that's completely crazy. We've never seen that before. So what do you think about that? You as as the CEO of an AI startup.
I think our world is going to continue to change. The solutions that they bring forth have an interesting challenge. One of the benefits of Nvidia's positioning in the industry is there tends to be a trend. In academia, you see sort of let me call them the brute force solutions. They focus heavily on model performance for classification, and then and as those benchmarks move, knowledge and understanding, and now reasoning and so forth. They focus heavily on the effectiveness of the model, and then at some point they begin to transition to the efficiency of those models, right? So Nvidia has a wonderful benefit in that they'll be the target platform in most cases during that strong research phase, and they have a well-designed architecture to allow them to be sufficiently flexible and to solve these problems in the let me call it the the brute force phase of things. If you look now at the papers that are coming out weekly, I'm guessing here, maybe half of them are these ideas. And we'll continue to follow that curve, but at some point it'll flatten. And it'll be solved with efficient architectures, solving the right problems in the right places.
Okay. Last question, because we have 30 seconds, but it's a question I ask everybody I meet in the AI industry. So are you afraid of an AI bubble or not?
Am I a friend of?
Of an AI bubble or not?
No.
No?
Nope.
No, you hope not.
Yes. I'm quiet in my own little space.
Okay, thank you very much again for being with me today alone. That was very interesting. Thank you very much for listening to us and at Web Summit. Thank you.